Greetings!
My name is Avissa Qonita, and here I am with my partner.
I'm Ayyuasy Vika, and you can call me Vika. In today's video, we will present to you a scientific report titled
Effect of Temperature and Biomass to Water Ratio to Yield and Product Characteristics of Hydrothermal Treatment of Biomass. But first, we have to know the actual condition, especially in Indonesia.
It's not a secret that our Earth has been facing environmental issues since several decades, including oil scarcity. That's why we need an alternative renewable energy. Certain materials such as biomass residues from wood is highly potential in Indonesia since we have many forests and trees. These materials is also cheaper and can be produced in big numbers.
The biomass from the woods contain lignocellulose, which can be converted into hydrocar, one type of biofuel, with hydrothermal treatment. This treatment is a water-based, which use water in the process. Other type of biomass conversion is dry-based. The water-based is highly favored since it costs more in dry-based process because biomass has high water content. But still, it is very important to analyze the best operation condition of hydrothermal treatment to produce high efficiency and retrieve the best desired hydrocar. In this video, we will focus on two variables of the process, temperature and biomass to water ratio.
Find the most efficient one. Different reaction conditions with various temperature and biomass water ratio are conducted for 30 minutes. One with different biomass water ratio are going to be conducted in constant temperature 250 degrees Celsius.
Using these variables, the best conditions are determined from main parameters of this study. First is the solid yield of product, which is the percent ratio of product mass to material mass, and second is energy densification ratio, which is the ratio of product caloric value to material caloric value.
Methods
and materials. Divided into three parts, the first step of hydrothermal treatment is preparation. Material sawdust are sieved using sieve and then chemically characterized. Next is hydrolysis.
The main focus in hydrolysis is to use water to break the material components and retrieve cellulose as desired product from the sawdust.
The last one is recovery. The solid part retrieved from hydrolysis, dried in the oven to retrieve the final solid product, also known as hydrocar.
First, we need an autoclave heated with a heater. Autoclave can be seen as the red one and the heater can be seen as the yellow one. Autoclave used for the main process, which is the hydrolysis of the sawdust using water as a solvent at a certain ratio. Then, we put the slurry containing sawdust plus water into the autoclave and seal it with a reactor cap.
Next, a stirrer is added to speed up the hydrolysis process. This happens because in moving condition by stirring, more biomass molecules collide with water. Next, N2 stream into the autoclave to purge area from air since air is more combustive in elevated temperature. Nitrogen were used because it is more stable so that no reaction with materials, and also since it is relatively low in cost. Since N2 has lower density, the air will be driven out to the release valve and after fully free of air, the nitrogen stream stopped.
Lastly, thermocouple is added to control various temperature. After each process at different temperature and biomass water ratio, the slurry is filtered and go into recovery step.
So, what do we achieve from this experiment? How does temperature to biomass to water ratio affect hydrocar product? Let's see the graph. At the end of the process, it was found that the lowest yield retrieved from the highest temperature process. Thus, the trend is negative. This happened because in higher temperature, more cellulose, which is the main part to create hydrocar, reacted with water so that the solid part retrieved at the end has lower hydrocar yield. On the other hand, the energy densification ratio is getting higher with increasing temperature.
The picture shows a graph with hydrochar yield as the y-axis and the biomass water ratio as the x-axis. As you can see, the research with different biomass water ratio shows a positive trend in the graph, in which more yield were caused by higher ratio. More solvent added to the initial biomass during hydrolysis will dissolve more cellulose, thus decreasing the yield. The experiment conducted on sawdust as lignocellulose biomass used hydrothermal treatment at various temperature and biomass-water ratio, with the result of yield vary approximately 38 to 69 weight% of the original material, while the lowest yield retrieved from the highest temperature and the highest yield retrieved from the highest biomass-water ratio. We kindly appreciate your attention until the last second of the video.
We also apologize if there is any mistake made.
I'm Vika.
I'm Avissa.
Thank you.
And have a nice day.